Universal Genève Polerouter, an icon of watchmaking history, once bold, precise and admired, now worn, tired and quietly waiting, but not forgotten. Today, I'm breathing life back into this legend. It's getting a new life, but its soul stays untouched. I'm starting restoration with inspection, and this Polerouter is seen better days. The caseback engravings are nearly gone, so restoring the caseback isn't an option. One touch of the polishing wheel and they vanish completely, so we leave it as is. Then disassembly begins. In the world of the watches, that means starting simple. Remove the strap, unscrew the caseback, and brace yourself for decades of dust, grease, and mystery. And once that bag pops off, we are in. The movement reveals itself. And this one, it's a dream for any watchmaking enthusiast. Because nestled inside is something special, a Microtor. Compact, elegant and mechanically brilliant. Next step is removing the movement from the case. That means dismounting the case clamps. And of course, one of them is broken. Not exactly a surprise. I've worked on enough Polerouters to know this is a common issue. Whether it's poor material choice or just a flimsy design, these clamps tend to fail. Fortunately, the second one is intact. That gives me a reference to fabricate a replacement. Not now, but it's on the list. With the movement out of the case, we can finally see the dial. And for a Polerouter, this one is perfect. No big damage, no heavy patina, just clean, sharp details. And the design? Glorious. First up for restoration is the case, which means dismounting the rest of its parts. Next is the glass. It comes out easily, with just a little resistance, and it's scratched, cloudy, not original and cracked. So it goes straight to the trash. This watch will get a new one. Next, the gasket, or what used to be a gasket. It's lost all elasticity, hardened it over time and now feels more like brittle plastic than rubber. So another thing to the trash. And finally, the crown tube. This is the tricky part. I'm hoping it comes out clean, without putting up a fight. So I reach for the proper tool, take a breath and go slow. And of course, the tube doesn't give up. It's stuck. Sees it in place after decades of sitting untouched, exposed to moisture and sweat from years on the wrist. No surprise there, so there is no choice. The drill will do the job. Finally, the case is fully dismounted, so we can begin polishing. I start with the hidden areas, like the back of the case and between the looks. These spots go first, because doing them last would risk compromising the sharp edges I will be refining next. I'm not chasing perfection here. These areas are mostly hidden, and spending extra time on them doesn't make any sense economically. Restoration is always a balance between the client's budget, the watch value, and the time invested. It's about making smart choices, not just shiny ones. After cleaning the case from the polishing paste, I can start lapping. The first edge to tackle is the face of the watch. At the beginning, I wasn't sure what shape it originally had. The case was too worn to tell. So I adjusted the angle on the lapping device based on what I guessed it should be. Loaded up some fine grit paper and began grinding. To check if I was on the right track, I used a marker to highlight the surface. That trick helped me see how the metal was being removed. And luckily, my guess was spot on. But the case is heavily distorted, so to speed up the shaping, I switched to a coarser grit. Then I moved on to the finer grits, gradually working out the scratches left by the previous passes. Each step brought the surface closer to its final form, and the texture started to even out nicely. Before I started lapping, I did some research online to see what the original finish on this watch face should look like. And to my surprise, it's supposed to be a vertical satin finish. Honestly, that design choice feels a bit counterintuitive. Applying a vertical grain to a case with this kind of geometry adds complexity to the process. Personally, I think a sunburst or radial finish would complement the curves much better and give the watch a more dynamic look. But it is what it is. Once I reached the finest grit, I switched over to the conventional polisher to line down that vertical finish. Meanwhile, I taped off the edges between the lugs to protect its polished shine and prevent any accidental scuffing while working on the face. The finish with a brush is not something that I adore, but it is like it is. Let's move on to the next step, which is lapping the corner edges. The corner edges on this watch are a horror. Adjusting the angles took nearly an hour. I didn't show this on video because I needed space without cameras. Just me and the tools. Two separate angles had to be dialed in, one on the tilt table and another on the case rotation plane. That's what makes it such a nightmare. These kinds of corners also show up on watches like the Omega Speedmaster or Seamaster. And because of how complex they are, I think I might be the first person online showing how to get them perfectly flat. Am I? As always, I started with coarse grit to shape the edges and remove scratches and dents. Lapping with coarse grit takes the most time. It's where the real work happens. The finer grits come next, just to make the edges shinier and more refined. But every step demands full concentration. One wrong move and wow, laser welding becomes only option. And if that happens, you are starting over step by step, all over again. You might be curious why I do not laser welded the scratches and dents before I started polishing, and there are two reasons for that. First one is the economics. I would have to weld whole case. And second one, I explained in my previous video with Zenith Defy, so check it out. Then I start polishing the edges using a special polishing cloth and diamond sprays. This step is where the magic happens. Conventional polishers with cotton brushes tend to compromise the flatness of the surface, which goes against the precision we are aiming for. The goal is near perfect flatness and flawless mirror-like polish. Achieving that requires the right combination of polishing cloth and diamond spray. I've tested nearly 10 different cloths from various companies to find the one that delivers the best results. It took a lot of time and a fair bit of money, but the outcome speaks for itself. So far, we've completed just two of the diagonal ends of the corner edges. Now it's time to tackle the remaining two. The process repeats, but this time angle adjustment becomes absolutely critical. These edges meet at the center, and the finish has to align perfectly. If it's even slightly off, we will end up with an ugly transition right where the edges join. That's how the case was designed. There is no workaround. It demands precision. Talking about design. Did you know that Gerald Genta designed the Polerouter? He created the Universal Genève Polerouter in 1954, when he was just 23 years old. It was his first major design, and it already showed the elegance and innovation that would later define his career. The Polerouter wasn't just a beautiful watch, it was built for a purpose. It commemorated Scandinavian Airlines polar flights, which flew over the North Pole and exposed instruments to intense magnetic fields. So Genta designed it with anti-magnetic properties to support the pilots on those pioneering routes. Even in that early work you can see the DNA of future icons like the Audemars Piguet Royal Oak and Patek Philippe Nautilus. Clean lines, bold presence, and timeless appeal. The Polerouter remains a dream piece for vintage collectors, and a reminder that genius can strike early. Okay, the corner edges are done. Now it's time to move on to the side edges, which should have a satin horizontal brushed finish. To protect the face of the case during this operation, I mount an old mineral crystal onto it. Then I adjust the tilt table, set up the coarse grit paper, and begin removing scratches, dents, and shaping the edge carefully. This part takes time, and I am not rushing. I'm working with coarse grit, and any mistake here could mean laser welding. So I take it slow. After a few careful passes, I start building the right texture on the center of the disc, because that's where the scratches naturally run horizontal. Once I get close to a perfect finish, I stop the machine and switch to hand finishing, moving the case along the lapping disc manually. I really like the finish this creates. It's aggressive, but not too aggressive. It catches the eye from a distance, but doesn't glow or dominate. Just the way I think it should be. And now, the last touch for the case. Polishing the back part of the lugs. I start with coarse grit to shape the surface, then gradually move to finer grits to smooth out the scratches. Finally, I polish it to achieve a mirror-like finish. It's a subtle detail, but it matters. The back of the lugs may not be the first thing you see, but it should feel just as refined as the rest. And with that, the case restoration is officially done. Now we move on to the heart of the watch, the movement. It's currently running and all functions are working properly, so there shouldn't be any drama here. That said, I suspect it was serviced not too long ago, but when I restore a timepiece, I don't take chances. I want to be absolutely sure everything is oiled correctly, the wheel clearances are precise, and there is no hidden dirt compromising performance. That means full disassembly, cleaning, and servicing. It's the only way I can guarantee the movement meets my standards. From experience, I know this particular Universal Genève movement can be quite tricky to service. And sadly, the plates bear the scars of past battles like scratches and tool marks, which are clear signs that someone struggled with it before. That's always painful to see, especially on a movement this beautiful and innovative. The movement I'm working on today is the Universal Genève Caliber 69. It's the thicker brother of the Caliber 66, a movement that, in my opinion, doesn't get nearly the recognition it deserves. Most people don't know this, but the Caliber 66 is widely considered the protoplast of the legendary Patek Philippe Caliber 240. Yes, that Patek Philippe. Let me explain. In the late 70s, the Swiss watch industry was in crisis. Quartz watches were flooding the market because they were cheap, accurate, and they were threatening to wipe out traditional mechanical watchmaking. Patek Philippe, like many others, needed to respond. But instead of chasing quartz, they doubled down on elegance and craftsmanship. They wanted a thin automatic movement that could rival quartz in wearability but still carry the source of mechanical horology. So what did they do? They discovered that Universal Genève had already developed the kind of movement they were looking for. So they hired Gerald Genta, a man who had worked at Universal Genève and was directly involved in developing the Caliber 66. Within 6 months of joining Patek, Genta helped lead the creation of the Caliber 240, a Microtor movement, ultra slim, beautifully finished, and unmistakably reminiscent of Universal Genève earlier designs. Coincidence? Maybe. Inspiration? Almost certainly. Depth? I won't judge. I'm not here to write history. I'm here to service it. But the resemblance is hard to ignore. The architecture, the rotor placement, the philosophy behind the design, it all points back to Universal Genève. And that's why I treat this caliber 69 with such reverence. It's not just a movement, it's a piece of horological DNA that helped shape one of the most iconic calibers in modern watchmaking. Sadly, many of these universal movements were mishandled over the years. Parts are scarce, tolerances are tight, and servicing them requires patience, precision, and experience. But when you look past the scratches and tool marks, when you really see the movement, you realize you are holding something special. Something that deserves to be respected and remembered. And there is good news for Universal Genève fans. The brand may not have survived the quartz crisis in its original form, but the birds are chirping, and this time they are singing about a comeback. After decades of silence, Universal Genève is preparing to return. And that means one thing. This might be the last chance to pick up their vintage pieces at a reasonable price, so don't miss it. Once the movement is taken apart, it has to be cleaned, not just on the surface, but deep down at the chemical level. It's a step many underestimate, yet it accounts for nearly a third of a successful movement service. Each part must be completely free of odd oils, dust, and most importantly, any trace of cleaning fluids. The choice of cleaning and rinsing solutions isn't just a detail, it's critical. Good choice of fluids dissolve dirt without harming delicate components, but too aggressive ones? They can eat away a shellac on the pallet and balance jewels, causing silent damage that won't show until it's too late. The right solution doesn't just clean, it restores. It leaves oxidation, shows that soft metallic sheen, and makes even vintage parts look like they were machined yesterday. Cleaning is where precision begins. Now we begin assembling and oiling the movement, starting with the mainspring and barrel. You can notice that the spring is shaped into two reverse direction spirals. Why isn't it just a regular spiral? We all want to wear accurate watches, and to achieve that precision, the movement needs one key ingredient: constant torque. Mainspring with a simple spiral generates torque which is strongest when the spring is fully wound, and weakest when it's nearly unwound. That inconsistency affects timekeeping. Engineers discovered that by shaping the end of the mainspring into a reverse curve, they could boost torque during the final stages of unwinding. This clever design helps maintain almost constant force on the gears, regardless of how tightly the spring is wound. It might look simple at first glance, but behind that elegant coil lies decades of innovation and deep mechanical engineering. With the barrel assembled, we can move on to assembling the gears onto the main plate. Each gear has a specific role carefully designed by watch engineers. Their tasks are to control the speed of rotation and transfer torque precisely from one gear to the next. This intricate dance of wheels ensures that energy flows smoothly from the mainspring all the way to the escapement and hands. Some gears in a watch movement have special roles, and in this automatic movement one of them is the ratchet wheel, which in this case is actually a double system. One ratchet wheel handles winding from the crown, and the other from the rotor. But here is the clever part. When the rotor winds the mainspring, you don't want the crown to spin. And when you wind the watch manually, the rotor shouldn't rotate either. If they did, it could cause unwanted vibrations or worse, damage the movement. To prevent that, the ratchet wheels are engineered to decouple both winding mechanisms, allowing them to operate independently without interfering with each other. It's a subtle but vital piece of engineering, and precision like this demands care. The ratchet wheel requires special lubrication to function smoothly and independently. It receives a thin Teflon coating that prevents the gears from sticking to each other. If you were to use oil with too high viscosity, it could cause the gears to bind, disrupting their ability to operate separately. That would compromise the entire winding system. This specialized coating not only prevents sticking, but also minimizes friction and wear, ensuring long-term reliability and flawless performance. Now we move on to assembling the gear train, starting with the second-hand pinion. This tiny but essential component sits atop a delicate spring which helps keep the second hand perfectly aligned in a vertical position. But this part comes with a challenge. The spring-load second-hand pinion makes it tricky to mount the surrounding gears and the gear train bridge. But there is a trick I use to make it work. I apply just a little pressure to the bridge. Then I look for the gear that's blocking it from dropping into place. Once I locate it, I gently nudge the gear until its pinion aligns perfectly with the jewel hole. It's a slow process. I go gear by gear, carefully adjusting each one. For beginners, this step can be especially frustrating. Those tiny pivots don't always want to cooperate. But with patience and precision, each pinion eventually finds its jewel hole and the bridge settles perfectly into place. With the gear train bridge secured in place, I move onto the barrel bridge. Beneath it lies a hidden but essential mechanism, the click and click spring. These tiny components play a vital role in the winding system. The click prevents ratchet wheel from rotating backward, which protects the mainspring from unwinding unintentionally. Next, I mount and grease the protective ring, the one that shields the bridge from wear caused by the rotation of the crown wheel. Then I move on to the crown wheels. I begin by oiling and carefully cleaning any excess lubricant from one of the two wheels, ensuring it's pristine and ready to function smoothly. With that done, I install the larger crown wheel, followed by a second wheel and its retaining plate. Once everything is aligned, I secure it all with a single screw. Next, I move on to oiling the jewels and bearings, a critical step for ensuring smooth operation and long-term reliability. The golden rule when choosing oils is simple. Smaller pivots get lower viscosity oil, while larger require higher viscosity. This ensures the right balance between lubrication and resistance. There is an interesting feature on the escape wheel jewel system in this movement. It looks a bit like an Inca block shock protection, but it's not quite the same. There is no spring action here, so I don't believe it's designed for shock absorption. Instead, I believe this dual setting is engineered to reduce friction at the escape wheel pivot, allowing the balance wheel to reach higher amplitude. That extra freedom translates into better timekeeping accuracy. But this step comes with a challenge. Handling the jewel with its setting is one of the trickiest parts of the entire assembly. It demands precise tweezers and a lot of muscle memory to avoid launching it into space. One slip and you are chasing a microscopic part that could vanish in seconds. Oiling it is also tricky. It's a delicate dance while still having it in tweezers. It's one of those moments in watchmaking where experience is everything. No diagram or manual can replace the feel, the timing and the steady hand required to get it just right. Then I move on to the opposite side of the movement to continue oiling the wheels. Each pivot and jewel here must be treated with the same care as those on the previous bridges. The wheels receive matching oils on their opposite side pivots to ensure smooth rotation, minimal wear and balanced energy transfer throughout the gear train. And now we have reached the gearbox of the movement, the keyless winding system. It's called keyless because we operate it with a crown, not with a separate key like in old pocket watches. This system allows us to wind the mainspring and set the time all through one interface. Did you know that the keyless winding mechanism was invented by Jean-André Philippe in 1842? His invention caught the attention of Antoine Norbert de Patek, and together they formed Patek Philippe in 1851. So while the patent wasn't filed in 1834, the innovation itself dates back on the early 1840s. And it truly changed the watchmaking forever. What is remarkable is that this system is still used today, and its layout remains strikingly similar across modern mechanical watches. The stem, crown, winding pinion, sliding pinion, setting lever and joke all work together to switch between winding and time setting modes with elegant precision. With our gearbox now mounted, it's time to install the clutch, known as the cannon pinion in watch industry. I mount it on the minute pinion, where it's gently clenched. It's designed to slip just enough during hand setting, allowing the hands to move, while gripping firmly during normal operation so the hands track time accurately. With gears between clutch and gearbox oiled and mounted, I return to the other side of the movement. Now I can store the energy I've put into the crown inside the mainspring. By holding one of the wheels, I trap that tension. But the moment I release it, all that energy rushes through the gear train and dissipates in just a few seconds. That's why the next step is so important. I'm moving on to the components that regulate this energy, starting with the pallet fork. The pallet fork is part of the escapement system. It acts like a gatekeeper, releasing energy from the escape wheel in controlled pulses. With the pallet fork now secured in place, I move on to lubricating its jewels. The pallet stones require a special low viscosity oil, designed to minimize friction while allowing precise impulse transmission from the escape wheel. For the pivot jewel, I use a standard oil suitable for small pivots. Some watchmakers choose not to oil the pallet fork pivot, arguing that it can lower the amplitude of the balance wheel. But in the case of a vintage watch, I prioritize reliability over peak performance. With everything prepared, I now carefully mount the balance wheel, the heart of the watch. Once in place, the balance wheel begins to oscillate, back and forth in perfect rhythm. It is this motion that divides time into equal parts, regulating the energy released by the escapement and ensuring the watch ticks with precision. Now I can oil the balance jewel, which sits beneath the spring designed to protect the balance pivot from damage during shocks. The jewel only needs a tiny drop of oil, right at the center. With the balance jewel secured in place, I now move on to the automatic winding system, starting with its backplate. Next come the reversing wheels, the reduction wheel, and the stop click. Mounting the jewel plate over these components takes time. These parts are incredibly tiny and under tension, especially due to the spring mounted on the stop click. You are probably curious how this automatic winding system works. At the heart of it are the reversing wheels. These clever gears allow the watch to wind the mainspring no matter which direction the rotor spins. That energy flows through the reduction wheel, which manages torque and smooths out the transmission. Then comes the stop click, a tiny but vital component that prevents the reduction wheel from rotating in the wrong direction, protecting the stored energy from being lost. Then I mount the oscillating weight onto its bearing assembly, the part that allows the rotor to spin freely with wrist movement. Inside this assembly is a tiny ball bearing, often hidden from view but absolutely essential. It ensures smooth low-friction rotation of the rotor. After securing the weight, I apply a small amount of lubricant to the bearing, just enough to coat the balls and reduce wear. With the rotor mounted onto the automatic winding system, I now move to the dial side of the movement. There are few remaining bearings to oil, starting with those from the automatic winding system followed by the pallet fork pivot. These are fairly straightforward, but the final one is the trickiest, the Inca block setting for the balance wheel. It takes time and steady hand, but we've got the experience. We just oiled the same one on the other side of the movement minutes ago. And now we arrive at the final components of the movement, the parts responsible for the date function. In this watch, it's a beautifully simple system. Just two wheels, one lever, one spring, a plate and the date wheel. No cams, no complex calendar modules, just clean, efficient mechanics. Sometimes simple is better. Fewer parts mean fewer things that can go wrong, and servicing becomes much more straightforward. It's a reminder that elegance in engineering doesn't always require complexity. With that, the movement is fully serviced, but there is one final step: adjusting the rate. So I put the movement onto my time grapher and you will see just how simple this operation can be. The machine listens to the ticks of the movement and displays key metrics like rate, amplitude, and bit error. From here, it's just a matter of making small adjustments to the regulator's arms to fine-tune the bit error and timing. Now we can move on to assembling the final parts, starting with the dial. I gently place it onto the movement and secure it by tightening the dial fit screws, making sure it sits firmly and evenly. Next come the hands. Since this is a date mechanism, I rotate the crown until the date changes. This marks midnight. Then I mount the hands at 12 o'clock, ensuring proper alignment for accurate timekeeping and date transition. But these hands, they've seen better days. They are scratched, bent, someone clearly had a fight with them. I honestly don't know how it's possible to ruin them this badly. But I have no choice. They are going back on. Now we move on to the case parts assembly, starting with the installation of a new crown tube. I apply a tiny bit of Loctite to the hole in the case, just enough to secure the tube without excess residue. Then using a plastic hammer, I gently tap the tube into place. It's a press-fit operation and Loctite ensures it stays firmly seated over time. Then comes the glass. This watch gets a brand new one. I mount it into the case using my trusty old Sternkreuz tool. Once it's fitted, I inspect it carefully for any dust or debris. With the crystal clean and secure, I place the movement into case, making sure it sits properly. Then I apply a small amount of grease to the crown tube and mount the crown. This helps maintain water resistance and smooth operation. With the crown in place, I move on to the case clamps. If you remember, one of them was broken. I made a new one off camera. It was a simple fix. I used a universal case clamp and bent it to fit this watch perfectly. Once the clamps are mounted, I grease the caseback gasket, seat it onto the case and screw in the caseback. And with that, after countless hours, steady hands and a battle of patience and precision, the Polerouter shines again. Thank you for watching and see you